All right. The ball bearings, rolling element bearings, they are standardized. We're gonna take a look of GM, General Motors bearing. On the book, page 517, there's a table for the GM bearings here. Okay, General Motors GM bearing here. And on 517, there's a table here. You have a different series, bearing series here, basic bearing number here. This L00, it means, this L, it means the diameter, and also L means extra light. And then 200 means the light duty. 300 is medium duty. And certainly this table is not complete. You have a heavy duty, extra heavy duty, 400, 500 here. Now this one here, the 00 number, corresponding to the hole, we call the ball. The hole, we call the ball. The ball diameter, this is in metric. So the ball diameter is 10 millimeter. 10 millimeter is about the size of my pen. Okay, the size of my pen, 10 millimeter. And then from L00 series to L01, 01 means the 12, the ball diameter is 12, to L02, 202, which goes to 15, L03 goes to 17. Okay, that's a ball diameter, the whole diameter order. If you turn the page, to page, let's say 550, then you will have the load, the capacity, okay, load capacity numbers for those. For example, the LR, which we know is a constant, 90 times 10 to 6. And then the C, you can go find the C here. Let's say if the ball diameter is 20, the extra light L00 series 20, you have 2.25 kilonewton here. Now 2.25 kilonewton, how much is that in terms of pounds? 1 pound is about 4 newtons here. So 2.2, I would say 500 pounds. 500 pounds. Now think of this, the bearing is not very big. It's about twice the diameter of my pen and take 500 pounds. So if you run 90 times 10 to 6 revolutions, cycles, you'll still have 90% of the bearings. If you have 100 bearings, you still have 90. That is good under such a huge load. So you can see the safety factor in our machines sometimes when we design that. Okay, now let's take a look at an example that is given by the book. Take a look at the example given by the book. I think the book has an example. Let's see. Yes, the sample problem 1. Let's take a look at example here. The example says, okay, if we have a number 208, radial bearing, radial ball bearing, and if we have a radial load FR equal to 4 kilonewton, that's about 1,000 pounds, okay, about 1,000 pounds, 800 pounds. And we want to find out what is L10 life. We want to find out that. What is L10 life? Okay, now if we constantly run 1000 RPM, the machine constantly runs that. How many hours this machine can run? Okay, how many hours it can run? We want to solve this problem here. Now, so number 208 from the book, page 574, and that table over there, I think it's 517. Page 517, the table. You find out page 517. From the table, you find out the bore diameter is, no, not 574. Okay, on that table over there, 547, I'm sorry, 547, not a 517, 547. Page 547, 208, page 547, 208. You will find out the bore diameter is 40. So the bore diameter is 40. So this one here, page 547, bore diameter is 40 millimeter. And then on next page, on the table, page 550, for the bore diameter, which is 40, and it's 200 series. It's 200 series, and you find out the C is gonna be 9.4 kilonewton here. 9.4 kilonewton. So C is 9.4 kilonewton. That's on page 550. Page 550. Over that. So you're gonna put in this L10, then is equal to LR C over FR 3.33. So you put in these numbers here, 90 times 10 to 6 times this one C is 9.4 kilonewton, and we have 4 kilonewton here, and kilonewton, they will cancel out. Make sure the units is the same here. Alright? And then you find out this one here, you use your calculator, do the calculations carefully, and you'll find out the numbers here is 1.55 times 10 to the 9th revolutions or cycles. That's gonna be the L10 life. Now if you run on 1000 RPM, how many hours? So 1.55 revolutions times 10 to the 9th. If you divide it by, that's how many revolutions, divided by how many 1000 revolution per minute, and then you get 1.55 times 10 to 6 minutes. And then this one, if you divide 60 minutes per hour, you'll get 25,800 hours. That's how many hours you can run. Okay. I'm gonna give you an assignment here that is due Saturday next week. Okay, that's on page. I need to double check that page here. I think it's 616, 14.11, 14.13, 14.15. Let me check here to see the page number is right. Oh no, the page number is not right. What's the page number here? Hmm. $11? No, that's not right. Okay, forget about that.